Another thing, the horizontal component of velocity is always same. So v naught cos theta is equal to v cos alpha at any other instant. The horizontal component of velocity must be same all the time. Another thing, we can use it, either call it conservation of energy or equation of motion. V square minus u square is equal to 2as. So this formula can also be used to find the velocity at any height y. And in case of horizontal throw, in such case of throw with horizontal plane, the maximum height is vy square by 2g, and range is 2vx vy by g, or we can write it as v squared sine 2 theta by g. And the time of flight for which the particle goes and moves down and hits the ground again, the total time is 2vy by g. And the time to reach the max height from ground, so the time to reach the max height from ground is vy by g, and it is same as the time taken to fall back, vy by g. And equation of parabola, we can find the equation of parabola using height and range, maximum height and range. Now, throwing on a slope, projectile on a slope. First, consider the case of throwing upward the slope. If the angle of slope is beta and particle is thrown at alpha angle with this slope, then the equations of range is this: cos alpha plus beta here, and for the maximum range, the alpha here used must be equal to pi by 4 minus beta by 2 when thrown upward the slope. And the equation of height and time of flight is simple, same as before here. V perpendicular by 2g perpendicular to the gravity component perpendicular to the surface, and 2v perpendicular g perpendicular means the component of gravity perpendicular to surface and velocity perpendicular to it, applicable to all cases. Now, when the object is thrown from a point downward the slope, then in that case, this positive signs becomes negative and this negative signs become positive. So you can think that up is positive here, and here it keeps negative, while down is a negative, so there is a negative sign here, and positive here, opposite here, opposite case, works here. And next topic is radius of curvature, but this is the formula you can remember. If x and y relation is given, then we can find radius of curvature by this method, or we can find radius of curvature by this formula. This is a normal to the velocity, and this is the total net velocity vector. There are formulas for radius of curvature of parabola and ellipse here. So let's say this is the longer side and this is the shorter side. These are the equations, and these are the radius of curvature at shorter side, at shorter right side. The radius is bigger and it is a square by b, since a is large, and rc at this point radius is small, so b square by a, b is a small value. And for parabola, radius of curvature is 1 upon 2a with these equations at this point only, these points. Now let's solve a question on projectile motion, some high level questions. Let's say a particle is thrown with a v velocity and it needs to cross the height h1, h2. These are two buildings